Okay, the last section that we're going to talk about in Chapter 3 is just proving and doing proofs, something all of us love, about different things. Different types of angles, parallels, perpendiculars. We're going to go through this section rather quickly because really all it is introducing you to some new theorems that you'll use later on in the year. And the way that the book and the way that we're going to introduce it is just by having you look at the theorem and maybe do a couple proofs. So we're going to go through this rather quickly. The first theorem that they introduce you to deals with two angles being congruent, angle 1 and angle 2. Remember that if in a diagram they give you tick marks, the tick marks represent congruency. So in this case, they tell you that angle 1 and angle 2 are congruent. How do they tell you that? Because both angles have one tick mark. If angle 2 had two tick marks and angle 1 only had one, well, that would tell you that they're not congruent, but both angles only have one tick mark, telling us they're congruent. This theorem says that if there are two angles that make up a linear pair or a straight angle, meaning they make a straight line, and they're congruent, angle 1 and angle 2 are congruent, then GH must be a perpendicular angle. And basically what that is saying is if angle 1 equals 90 and angle 2 equals 90, then GH is perpendicular. The only example that this ever works is if angle 1 equals 90 and angle 2 equals 90. The reason is they have to be congruent angles. If they're not congruent angles, then you'll never get a perpendicular line. The following theorem just says that if you have two perpendicular lines intersect, that was a horrible drawing, excuse me. If you have two lines that intersect, like A and B, they intersect to form a right angle, like angle 2. But what you should also know is that because vertical angles are congruent, angle 3 is also 90 degrees. And because both of these form a straight line, angle 1 plus angle 3 must equal 180. Angle 2 plus angle 4 must equal 180. And if angle 3 is 90, then angle 1 has to be 90. If angle 2 is 90, then angle 4 has to be 90. Therefore, going a long way about to say it, if you have two lines that intersect to form one perpendicular angle, then it actually forms four perpendicular angles, just by nature of the way they all add up. We're not even going to do example 1. You could cross that off on your paper if you want. The next theorem says that if two sides of two non-adjacent acute angles are perpendicular, then the angles are complementary. All that is saying is this, that if you have a right angle, and in that right angle you have two smaller angles, then the angles are complementary. Duh. Meaning if angle ABC equals 90 degrees, watch, angle ABC equals 90 degrees, and angle 1 plus angle 2 equals 90 degrees, or excuse me, sorry about that, angle 1 plus angle 2 equals angle ABC, then we could use the transitive property or the substitution property to say that angle 1 plus angle 2 equals 90 degrees. That is something that I don't even know why they need a theorem for. That is something that you should be able to use deductive reasoning and say, if angle 1 and angle 2 added together using the angled addition postulate make up this bigger angle, and the bigger angle is 90 degrees, then angle 1 and angle 2 have to be complementary angles. That is something that I don't think should take a whole lot of thought. They want us to prove it. This is a rather annoying proof, and I'm going to show it to you, and you'll see why it's annoying. They pull out a couple steps and reasons that you don't really use a lot in geometry. You don't even use a lot in the real world. We could do exactly like what we just did up here using the substitution property. We're given that angle DEF is perpendicular. we're given that ED and EF are perpendicular, meaning, well, let's start off. ED is perpendicular to EF. That is given. What that actually means is that angle DEF is a right angle, and that's just the definition of perpendicular lines. Well, if DEF is a right angle, then DEF equals 90 degrees. That's the definition of a right angle. You can see we're using a lot of definitions, which is dumb, because everybody in the world knows that if something is a right angle, it's 90 degrees. We don't have to say that's the definition of a right angle. Well, then we can say that angle 1 plus, or excuse me, not angle 1 and 2, but angle 8 and 7. Angle 7 plus angle 8 equals angle DEF. That is the angle ad postulate. You can see now we're doing exactly like what we did up here. I can say that I cross off that DEF and cross off that DEF. Angle 7 plus angle 8 equals 90. That's the substitution property. And then angle 7 and angle 8 are complementary, exactly what they wanted me to prove, and that's the definition of complementary angles, because if they add up to form 90 degrees, that's what a complementary angle does. So again, you can see we did 3 definitions there. That is why it's annoying. You and I would know that if this angle plus this angle equals this angle, and this angle equals 90 degrees, we can use the substitution property to say 1 plus 2 equals 90, or in this case, 8 plus 7 equals 90. We don't need to write a 5-step proof, or excuse me, a 6-step proof saying that. Understand what the theorem says, and all the theorem is saying is basically the angle addition postulate. There's this one, the perpendicular transversal theorem, saying that if you have 2 parallel lines, like H and K, and you have a transversal that is perpendicular to one of them, the transversal is also going to be perpendicular to the other. And the reason is, let me show you. If we have parallel lines cut by a transversal, 3 sections ago, you learned something about corresponding angles. Corresponding angles are what? I hope you are saying to yourself, corresponding angles are congruent. So if one of them is 90 degrees, the other has to be 90 degrees. Again, why we have to have a special theorem that says that, I don't know. Because all you're doing is applying the corresponding angle congruency theorem. It's the same thing. If you have 2 parallel lines cut by a transversal, then corresponding angles are congruent. If one of them is 90, the other has to be 90. Now we have another one that says the exact same thing. Lines perpendicular to a transversal theorem. In a plane, if 2 lines are perpendicular, like this, if they're perpendicular to the same line, then they're parallel. Well, let me ask you this. If you have 2 angles that are congruent, what kind of angles are they? Holy smokes, they're corresponding angles. And if corresponding angles are congruent, then the lines are parallel. We spent an entire section talking about this. Why they have a new theorem that says the exact same thing, I do not know. This is a section in the book and in geometry that is almost wasted. It is a pointless exercise in making sure you understand corresponding theorems and corresponding angles are congruent. That's it. That is all of chapter 3. This section just kind of gives you a few new theorems dealing with perpendicular angles, complementary angles, and lines perpendicular. three ideas that you have already seen. You already know about perpendicular angles. You already know about complementary angles. Hopefully you're very good at them. And lines being perpendicular because they form or they meet at a right angle. Hopefully you already kind of know these three, and so this section will be very, very simple. That is the end of chapter 3. So let's take a look at your homework now.